Hey everybody, today we're doing 9-7, which is solving quadratic equations using square roots. So I want you to remember that a square root has two answers. It has the positive and the negative, and we'll use this symbol. It's like a little plus on top of a minus to show that. You also need to remember that you can't take the square root of a negative. You will do that in Algebra 2. And then also that this whole thing we're still finding the zeros, or where the graph crosses the x-axis. That's the whole goal here. So don't forget that this still relates to the graphs that we've been working on this whole unit. So for each example, we're going to solve, and then if we get a decimal, we're going to round it to the nearest hundredth. So example 1, since I have the x squared isolated, all I'm going to have to do here is take the square root of both sides. So to undo a squared, we take the square root. And then I'm going to have positive and negative, the square root of 169. If you aren't sure of that one in your head, the square root on the calculator, you can't see that, is right here, above the x squared, conveniently, because the opposite of squared is square root. So you type second, and then that button, and then type in whatever number you need. Different programs look a little bit different on the calculators. Enter, we have 13. So don't forget though that I need positive and negative 13 there. And that's because positive 13 times positive 13 is 169. Negative 13 times negative 13 is also 169. That's why you have those two different answers there. Okay, example 2, we would take the square root of both sides. And then right here, I am trying to take the square root of a negative. We can't do that. So this is no real answer, or no real solution. This would be one that if you looked at it, it would not cross the x-axis. All right, example 3. So notice on all of these examples, it doesn't have an x term. So when you just have the x squared and the number, that's when you want to use the square root to solve. It's the easiest way. You could do factoring, all those different kinds of things with this too, graphing, everything that we've looked at, but the square root is the easiest way here when you have an x squared and a number. So on example 3, I need to get the x squared piece by itself. So I'm going to subtract 7 from both sides. I'm left with x squared equals 0. And then if I take the square root of that, square root of 0 is saying what number times itself is 0? Well, that's just 0. Okay, so this would cross the x-axis right at 0. And remember, we can always type these in to check and see to make sure our answer makes sense. So if I go to y equals and type in x squared, that's actually the parent function. So the spot that it's touching right there, that's the only 0. Okay. On example 4, we need to first add 49 to both sides. Now we're going to have 16x squared equals 49. Divide by 16. Okay, now I'm going to pause here because I'm not going to divide those, because I look at that and I can see that those are both perfect squares. 49 is a perfect square and 16 is a perfect square. So when I take the square root of these, it's like I can just take the square root of both of those pieces. So this is going to become x equals positive and negative. Square root of 49 is 7. Square root of 16 is 4. So positive and negative 7/4. And if you need a decimal approximation for that, 7 divided by 4, 1 3/4, or 1.75. So this would be crossing at here and here. Okay, so we're getting into stuff where it doesn't cross exactly through a point on the x-axis. So this would look something like this. Just a rough sketch. Okay, number 5. Take the square root of both sides. 15 is not a perfect square, so if we type that in, second x squared, that gets us the square root, 15. And then we are going to round this to the nearest hundredth. So I have tenths, hundredths, and then I look one place over. 2 does not round a 7 up, so this is going to stay 3.87. And we should have this as approximately 3.87. And same type of process happening here. So we are going to solve for x squared, get that by itself. Subtracted 90 from both sides, divide by -3. 90 divided by 3 would be 30. Take the square root. Don't forget that you have to have your positive and your negative, and we're going to type in square root of 30. Gives us 5.477, so you can't see that, sorry. This 7 is going to round this 7 up to an 8, so I'm going to say it is about 5.48, positive and negative. All right, and last one. It says, I am building a retaining wall along one side of the classroom to keep unruly students out. Classroom is twice as long as it is wide. It also has an area of 578 square feet. What would be the length of the retaining wall? So whenever you have a story problem, the first thing you should do is draw a picture. We have a rectangle. So if you do this on a quiz or test, if you draw a picture, you at least got a point. So here's where my retaining wall is going to go, and then I know that my area is 578 square feet. Okay, we also know that it is twice as long as it is wide, but we don't know how wide it is. So I'm going to say x is going to be the width. And then if the length is twice that, I'm going to say 2x has to be the length. So now I have x and 2x. If I'm finding the area, length times width, that would be x times 2x has to equal 578, because that's what they said the area was. So this is 2x squared equals 578. Now we're going to solve. Divide by 2. Half of 578 is 289. And now take the square root. Square root of 289, is that a perfect square? It is, that's 17. So remember, we would get positive and negative 17. And this is where we have to think about, does a negative answer make sense? If I have negative 17 as a length, would that make sense? No, so I'm going to just use the positive answer here. But remember, 17 is what x is, and the length here that we're looking for is actually 2x. So 2 times that 17 means that my retaining wall is 34 feet. Okay? And joke, which you may have heard, how do you make a tissue dance? You put a little boogie in it. Have a good night.